Whoops. That's a -3. Right, did you get something like this for the first one, guys? All right, and just make sure you put the arrows on there to show the orientation. So it starts here and it goes this direction. So whenever we eliminate the parameter, we should get something that's like a parabola, like we should get a squared in there. So which one is easier to get t by itself, for the x equation or the y equation? Definitely for x. How would you get x by itself? So 1/2 x equals t. And you just take that 1/2 x and plug it in for t in the other equation. So you're going to get y equals negative 1/2 x squared plus 1. And that would be negative 1/4 x squared plus 1. So since we ended up with y equals, I need to state what our domain is for x. And you can either look at the table. I generally just look at the graph. What are our x numbers like staying in between here? Yeah, -4 and 4. Nice job. I believe in you. Are you ready for me to start this one? Or at least like write out the table? I don't want to get ahead of you because I want you guys to get a chance to try it, but I also want you to be able to check it before you leave. I usually just look at the graph. So like if you look at the graph, your x's are staying between -4 and +4. Like I know that's sort of a silly answer, but I just look at it and see what they are. The other thing is you can look at the table, like for your x numbers here and say, oh, they're staying between -4 and +4. So did you get like a oval?
Yeah.
It's technically called an ellipse, but and going around clockwise. You didn't have to eliminate the parameter for that one because that would involve like arc trig, and I didn't want you to have to do that. Let me just do number 3 as well, and then I'll be quiet again and let you keep working. All right, so it says write parametric equations. That means you need an x equals and a y equals. That's what your answer should be. The x equals is actually pretty easy to get. You're just going to use this equation and get x by itself. So x would equal what if you get x by itself here? 4t. Okay, so that's the answer for the x equation. How would you get the y equation? Plug 4t in for x over here. So it'll be 2 times 4t squared plus, oh, I guess that would be 6 times 4t. There were 2 x's there where you had to plug in. And then you just simplify that down. So this would be, 4 squared would be 16. But then you have to double it. So 32t squared plus 24t. So when it says to write parametric equations, your answers should be an x equals and a y equals. All right, derivative of y would give us what? Good, and why is it 6? It's chain rule. It's that, and then you have to times on is 3. Okay, and then derivative for x. So derivative of sine would be cosine t over 2. But same thing, you have to chain on the derivative of t over 2, which would be 1/2. And then just to simplify that down a little bit, 6 divided by 1/2, that would be 6 times 2. So it would be 12e to the 3t over cosine t over 2. Cool? I'm just going to finish going over the rest of it for you. All right, this is the second derivative. So first, let's do the first derivative. Same thing that we just did in the last problem. What's your derivative of y? 12t squared minus 5. Derivative of x, 3. I like to simplify that down first before I go on to the next step, because then you're using something that's simpler, okay? So we're going to take both of these and divide them by 3. So it would be 4t squared minus 5 over 3. And then we're going to do the second derivative. So we're going to do the derivative of that and then over dx dt again. So what is the derivative of this? 8t. And then derivative of x was just 3. And you can't reduce 8/3, so actually that's it. Simplify this first before you go on to the next step, because then I know, and it like, I get that. You could actually do a quotient rule and make it work. It would be way more Did you try the quotient rule?
Oh, no, I didn't.
Oh, you were just like, whatever. Okay. Well, simplify that first, because then the 5/3 is just a constant. Like, I know it's a fraction, but you don't do anything with that. See how there's no room for this one? Because you really don't have to do much. All right. What would the slope be? Well, slope means what? Yeah, dy dx means derivative. So what's derivative for y? 7. Derivative for x. That's it. All right, this is asking for vertical tangent. Is that dy dt or dx dt equals 0? Dx dt equals 0. So you actually have some extraneous information in this. Do you even need this y equals at all? No. So like, you're not even going to use that. So what is dx dt? What's our derivative for this thing? Good. And then this is just going to be an algebra problem. We're going to factor that. So how will that split up? We forgot how to factor. How do you split 3? Well, I'm just asking how to split this. 3 and 1. 1 would be 1 and 1. And then they're both negative. Good. So we would get t equals 1/3 and t equals 1. That's 2 places where you have a vertical tangent line. Could that happen? Yeah, because these aren't necessarily functions. They can do all kind of loop-the-loops and weird things, as we've seen. All right, this one is asking for an equation. That means you need what 2 things? All right, I gave you the point. So what you need is the slope. Slope comes from the derivative. So what's your derivative for y? 8t. Derivative for x. That's a little tricky. Let me like do a side problem for that. I would rewrite that as -1t to the -3rd. And when you do that derivative, bring down the -3. It's going to cancel. It'll be +3t to the -4. And so when I write it back in the problem, it would be 3/t to the 4th. Just do like a little side problem, like off in the margin or off to the side, right? And what are we plugging into that? Actually, we don't know. We have x and y, but we don't have t, okay? So you can either plug in -1/8 for x, or you can plug in 16 for y and solve it for t, but you have to find t, somehow. I know at first glance it looks like the y one is going to be easier, but it's not. And that's because there's a squared, which means you would eventually have to square root, and you don't know whether it's plus or minus. So I'm going to do the other one. Stay away from squareds and square roots. That just causes problems, okay? So what was x? -1/8. I'm going to take -1/8 and set it equal to -1/t³. That looks scary, but it's actually not too bad, because what's going to happen? What happens to the negatives? Yeah, they cancel. And what cubed gives you 8? 2. So t is 2. So like, it looked kind of scary, but it actually wasn't that bad. There were negatives and fractions, which I know are the 2 like worst things in the world. All right, so we're still trying to find our slope. Kind of had to go on a little scavenger hunt there. We're going to plug in 2 for t and see what we get. All right, so 8 times 2, 16. And then this would be 3/2 to the 4th would be 16. And I'm going to have to sort of sift through that. When you divide by a fraction, you multiply by reciprocal. So this will be 16 times 16/3. Does anyone happen to know 16 times 16? It's 200 and something. Good job. 256/3 is our slope. Good job. I figured somebody usually knows it. I know it's like an obscure one, but Somebody usually knows it. All right, so here's your point. Here's your slope. Just put it all together. It'll be y minus 16 equals 256 thirds, parenthesis, x plus an eighth. So just be careful. You have to plug in t, and if it's not given, you have to find it. But if you have an x and a y, just pick which one you're going to plug into and then solve for t. It's usually not that hard to solve for t. You just have to do it. And then this is the stuff we covered today. This will be integral from where to where? 0 to 1, draw a gigantic square root, blank squared plus blank squared dt. Just draw it out blank. So what's your derivative for x? Looking at this one right here. 2t to the 9th. And then derivative for y, that would be 2/4, which would be a half t. And I'm not going to make you evaluate it, but I do want you to simplify it down. So what will you get for this first part? 4t to the 18th plus 1/4 t squared. So that's the answer I'm looking for there. So you don't have to actually like go the whole way through and do the antiderivative, but I do want you to simplify it down.